have here inverters. There's 3 of them, and they can only produce 208 volts. We have a generator in another building that produces 208 volts as well, but our pump right here, which is 600 feet down the ground, has to have 230 volts 3-phase.
So what do we do? In this situation, he has this 230 volt pump motor that he needs to supply electricity to, and the voltage that he has is 208. So what do we do? Well, you probably already guessed, we use a buck boost transformer. Let's talk about buck boost for a minute. A buck boost transformer, what is it? Well, it's an auto transformer, which is an electrical transformer with only one winding. All right, let that sink in for a minute. A transformer with only one winding. Portions of the same winding act as your primary and your secondary, and we'll get into that in just a second with a diagram. The winding has at least 3 taps where connections are made. Some of the advantages of buck boost transformers are that they're smaller and lighter and cheaper than just a regular transformer with taps. But they don't provide any electrical isolation because it is just a single winding. Auto transformers or buck boost transformers are generally used to step up or step down the voltage. Typically your 110, 117, 120 voltages and your 220, 230, 240 voltage range. 99% of the applications for a buck boost are just what in Brad's situation scenario was, where he had 208 and 230. Those were the 2 voltages that were conflicting, where we had to reconcile and either bring 208 up to 230 or buck it down from 230 down to 208. So as I was saying, let's look at this in a kind of in a schematic. Here's what a buck boost transformer diagram kind of looks like. We just have this one big winding with taps where we want them, where the engineer said they need to be. And so these we can use as our secondary lines, and these we can use as our primary lines. And depending on the voltage that we have available and the voltage that we want, our wiring diagram is going to tell us how to hook up which of these leads to our equipment and to our line to get the desired results. So you're a little bit familiar with a typical dual voltage single phase transformer, where you have your 2 primary windings and your 2 secondary windings. So you've got your X1, X2, X3, X4, and your H1, X2, H2, H3, H4. And you know how to take those and hook them up to get the right voltage here and the right voltage here that you want. Well, what we've done in a buck boost transformer is we're going to connect these 2, maybe. We're going to connect these 2, and then we're going to connect these 2. So if you twist this around, what you get is this. If this is totally blowing your mind, go to YouTube and search auto transformer or buck boost transformer and watch a couple of videos, and hopefully it'll sink in a little bit better. So what we've done is twist this around and make it into a single winding. So here we have a very common, simple, single-phase transformer, half a kVA, high voltage 120 by 240, low voltage 12 and 24. So we've got this 10-to-1 ratio here. So if we want to hook it up as a single-phase dual voltage transformer, here's our easy connection diagram right here with our just nice H's and X's. However, the potential for this transformer is not limited to that. First of all, let me show you a couple of things. We have it's sealed in here. You can't see the windings up inside, but we've got our leads coming out. We have a smaller gauge wire here, which will be our high voltage, that's right, and our thicker gauge wire down here, which will be our low voltage. Now the low voltage is going to carry more current, right, and our high voltage is going to carry the less current. So that's just kind of when you're just looking at a transformer, you can kind of tell your high and low by the size of the wire. But also, each of the wires is labeled on it, H1, H2, and so forth. Okay, so you can connect it with using this diagram if you need. However, if you need to use it as a buck-boost transformer, it comes with wiring diagrams for all kinds of bucking and boosting applications, even in open delta or just a regular three-phase, and even a single-phase chart. Now this is a single-phase transformer. If you wanted to do one of these, you would need more than one transformer to hook it up with an open delta or a three-phase configuration. So let's look at one scenario. Maybe you have 208 volts and you want 230 volts. There it is right there, and you go to your wiring diagram 4 and you can connect it to boost the voltage up. So now back to Brad's situation. He had a 230 volt pump and he had 208 volt three-phase available. So let's see if we can use this transformer. Because it's three-phase, we're going to need more than one. This particular transformer allows us to step up from 208 to 230 in either an open delta configuration or a three-phase Y configuration. The difference is with a three-phase, we would need 3 transformers, and with open delta, we would only need 2. So being the pinch pennies that we are, we'll do open delta and go to this 208 or boosted up to 230 volts. So that's going to take us to diagram 12 in this information that came with the transformer. And here it shows us where our high voltage connections are made and where our low voltage connections are made. I want to have you look at that and absorb it and see if you know how to make those connections, this transformer, these H1s and X1s, how do you connect those together? Look at this and do that on your own. If you have any problems, talk to your journeyman or give me a call. This is the meat and potatoes of buck-boost transformers. Being able to select the transformer and being able to wire it properly so that you get the desired voltage that you need.
Go ahead. Okay, this is an application where we would use buck-boost transformers to boost our voltage from 208 up to 230 volts. I have here inverters, there's 3 of them, and they can only produce 208 volts. We have a generator in another building that produces 208 volts as well, but our pump right here, which is 600 feet down the ground, has to have 230 volts three-phase. So what I've done is I've come from my 208 volt panel and I have brought the wiring from that 208 volt panel up through here. That's a black, red, and a blue. We're going up to my buck-boost transformers, and here I chose to use an open delta system because that's all I needed, and the transformers were plenty big. The 208 comes up, goes through the transformers, comes back down here to the main disconnect in this pump panel at 230 volts. This then goes down and feeds my drive to start the pump at 230 volts and feeds 230 volts to my pump.